Hello, it's Mr. Cablan here, and I'm here to present the second lesson for Chapter 5, dealing with what's called partial variation. Now, before I begin, I just want to do a quick recap of what we did in the last lesson dealing with direct variation here. So if we take a look at the last lesson we looked at, just do a quick summary. Okay, remember that direct variation, all equations are given in the form of y equals kx. And just as a reminder that the k is what's called the constant of variation. And we learned from the last lesson that the calculation of k, or the constant of variation, is exactly the same thing as the calculation of rate, which we looked at at the beginning of this course here. Now, remember, we also look at the graph, which you see on the screen here, is that all lines or all graphs that are direct variation start or pass through the point 0, 0 or the origin. Okay, so those are some key features of direct variation. So when we're looking at the next part over here, what we want to do now is to take a look at partial variation. So for partial variation over here, okay, and what we want to do here is to obviously look at what partial variation is, but we're also going to look at the difference between partial variation and direct variation. So let's take a look at partial variation first. All right, so what is partial variation? Well, partial variation and all equations that are partial variation are in the form of y equals mx plus b. Okay, so notice they have a couple of things in common from the last lesson. There's a y and there's an x. Okay, but you notice there's two different letters here, which are the m and the b, and I'm going to explain that in just a moment here. Now, the b is the big difference because this was not present in the last formula that we saw with direct variation. And what the b represents, okay, is what's called the fixed or initial value. Now, you're probably wondering, what in the world is that? Well, this b here, believe it or not, is this point here on this graph. So what is the difference graphically between partial variation and direct? Well, as you can see in the example over here, for partial variation, it's any graph that does not start at the point 0, 0. Okay, and that includes lines that start below 0 over here. So anything that starts above 0 or below 0 are all examples of partial variation. Now, the m represents what's called the constant of variation. Now, you're probably thinking, well, that sounds familiar. Well, yeah, it should, because you actually heard the same thing in the last lesson. Okay, now the only difference, believe it or not, is the letter itself. Okay, in this equation here, notice what we have here is y equals mx plus b. And in the last lesson, what you had there was y equals kx. So the only difference between k and m, okay, is just the letter itself, but they mean the exact same thing. Now, just a little bit of a heads up here. Later on in this chapter, you'll also discover to learn that m also represents the slope of a line, but we'll look at that in a future lesson. Just giving you a heads up. Now, what you do need to know about the graphs, as I mentioned already, is that any graphs that do not start at the point 0, 0 are all examples of partial variation. All right, so let's take a look at some examples over here. So what we want to do first, again, is we have a table of values for x and y respectively. And what we want to do is to finish it, because you notice we have 3 blanks that we need to finish. So it says look at the y values and look for a pattern. Now, what we want to do here is to use the first 2 values and see how we can go from 6 to 10. So if you look at 6 to 10, keep in mind what we want to do here is to find the difference between them. So to go from 6 to 10, for example, what we're doing here is going up by 4 or adding 4. So as we continue, we have 6 and 10. When we add 4 to 10, that will give us 14. When we add 4 to 14, we get 18. Okay, and it makes sense. If we add 4 to 18, we get 22. Add 4 to 22, we get 26. So what we've done here is completed the table to help us answer the next set of questions. So for part B here, it's what is the initial value of y? Now, what's very important is what I'm going to write down next over here, because this is how you find the initial value of any chart that is provided for you. What you want to do here is to look at the y value when x is equal to 0. So if you look at this chart here, first thing you need to do is to find out where the x equals 0 is. And boom, it's right here. Now what I'm going to do there is highlight that so you can see that the number that is right beside that 0 is the number 6. So this 6 here, that's going to be the initial value of this particular relationship. All right. So that's how you find the initial value of any table of values. Just look at the value of the y when x is 0, okay? And there are no exceptions to that. Now for part C over here, it says, what do you notice about the y values as you go down the column? Well, we kind of answered that question earlier because the pattern that I asked you to do just a couple of seconds ago, well, that happens to be the pattern that's going to tell us what the value of the constant of variations will be. So as I mentioned earlier, each one of these is going up by 4. And this 4 here is going to be the constant of variation. So let's fill that in accordingly. All right, so what do we have so far? We have two numbers. We have the initial value of the y here, which is 6. Okay, and we have the constant variation here is 4. Now, these two numbers are going to be very important for this last question. So it's using the initial value and the constant variation, write an equation in the form of y equals mx plus b. Now, what you have to understand here for any type of equation is that we always need to replace the m and the b with some numbers. And believe it or not, the sum numbers are already here. So you can see here, starting off with this first part, okay, the m here is the constant of variation. Well, what's the constant of variation here? We discovered it to be 4. So the 4 is going to replace the m, which I've highlighted in pink there. And last but not least here, the initial value of y, this 6, that's going to replace the b. So the equation of this table, okay, you notice that we've just looked at this table alone. The equation of this table will be y equals 4x plus 6. Okay, so let's do a quick recap. We found the pattern in the numbers, and we discovered that the numbers were all going up by 4. This was the constant of variation. The initial value of y, we looked at the table, is the value of the y when x is equal to 0. Now that value there, which was 6, that goes in for b. And that's how we came up with this equation. All right, let's move on here. So the next thing what we want to do here is we want to graph this, and each one of these, as we go down the column over here, each one of these is an ordered pair. So for example, what we have for the first one here is 0, 6. So at 0, I'm just going to go up 6. For 110, I'm going to go right 1 up 10. For 214, I'm going to go right 2 and up 14, and so forth. Okay, so as you can see, when I finish this, we now have 7 points, which we can draw with a straight line. Now, for the next part, after you graph it, it says describe the graph. Well, step number 1, let's state the obvious. What we have here is a straight line. Okay, now you're probably thinking, well, how is that different from the lesson we did yesterday on direct variation? Well, the difference is the next part of the answer. Notice that this line here does not start at 0. So since this line does not start at 0, this is an example of partial variation. All right, hope that clarifies things there. So let's take a look at the next example, and let's take a look at a word problem. So for this one over here, obviously a DJ problem, surprise, surprise. All right, so we got DJ Mateo is a club DJ who charges $500 plus $25 for each hour he works. So what I want you to see here is that we're going to take this one statement and we're going to change that and convert it into an equation by breaking it down here. So let's take a look at the second part of the question. So it says here, what is the fixed cost for DJ Mateo's services? Now, what you need to know about the word fixed here, and if you really think about it, when something is fixed, okay, it means something that doesn't move. Okay, so if you look at these two numbers over here, just to analyze this, of the two sets of numbers in this question here that do not move, okay, guess what? It's going to be the $500, okay? And that here is the fixed cost, and in some cases, this is also called the base fee over here. So what this means here is that if it doesn't matter if DJ Mateo works 1 hour or 100 hours, he gets that $500 up front. All right, so next part, for part B, we're going to look at the variable cost here. Now, the key thing that you have to understand about variable, okay, if something, the key word or the root word in variable is vary, which means it changes. So if you look at this example over here, there's only one number that changes, and it's going to be this $25. Now you probably want to know, how do we know that? Notice that if you read the rest of the question here, there's $25 for each hour. So that $25 changes depending on how many hours he works. So in this case here, the rate of pay, that's going to be the $25. All right, so we have the two numbers. Now we have to put that all into an equation here. Now you notice for part C, it tells us what letters to use. So it says here, using C to represent total cost, and H should represent the number of hours. Write an equation that represents this relationship. So starting off with C here, we know that total cost is equal, the grand total or the total cost, that's going to be equal to something. So you're going to start off with C equals. Now the next thing you're going to see here, okay, is we're just going to do it exactly the way we read it. So we're going to start off with the $500. Now remember, the $500 doesn't change. So we're just going to write that down as 500. Okay, I also just want you to see that the 500 on its own, okay, it's exactly it. It's on its own. So that's going to be the fixed cost or upfront cost for this problem. Okay, and now you can see here we're looking at $25 per hour, and H represents the number of hours. Another way to think about that is 25 times H, which gives us, well, 25H. Now, since we're adding it, we're just going to put this as 500 plus 25H. All right, so notice how we took a simple statement and changed it into a formula or equation. Now, for the next part of the question over here, it says use the equation from C. Okay, determine how much DJ Mateo will earn if he plays for 7 hours. Now, going back to this question, remember we have what you need to do first is just to understand what the two letters represent. So we have C to represent total cost and H to represent a number of hours. So what we need to do here is to take this 7 and then substitute it in for the letter H. Now remember, when you substitute a number in for a variable or letter, always just put a number brackets around it. And if you put that in your calculator carefully, you should get a final answer there of $675. And that wraps up this lesson for today here. All right, so that wraps up today's lesson on partial variation. Just do, again, a quick summary over here. If we go back to the first slide, okay, just remember with partial variation, okay, you're always going to have a graph that does not start at 0. Okay, the M again represents a constant of variation, and the B here is going to be where the line crosses or touches the y-axis. Okay, so those are just some of the important concepts that I just want to quickly revisit before I let you guys go. All right, and see you in the next lesson.